Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about binary arithmetic. Now, in binary arithmetic, we're going to be talking about binary addition, binary subtraction, binary multiplication, and binary division. Alright, so I'm going to take you through these operations step by step. Now let's talk about the addition rules. The first rule says 0 plus 0 is going to be 0, 0 plus 1 will give us 1, 1 plus 0 is going to give us 1, 1 plus 1 is going to give us 0 with carry 1. It means we're going to have a carry of 1. And then finally we have 1 plus 1 plus 1 equal to 0 with a carry of 1. So I'm going to explain to you how we're going to apply this carry in our first example. Alright, so let's take into account the first example. Now the first example says, what is the addition of 1001 and 1011 in binary? So this is nothing but in base 2, that's binary. Now this is a solution just like the way you carry out your normal addition is exactly what we're going to do, but in binary. Now let's proceed. You have 1001 and you have 1011. Now this is binary. Let's go. The first one says 1 plus 1. Remember, it's going to give us 0 with a carry of 1. So we're going to carry that 1, add it to this part. So we're going to have 1. So it's going to be 1 plus 1. We're going to have 0. And then we're going to have carry. Alright? We're going to have carry of 1. We take that 1, place it at this bit. So we're going to have 1. So we say 1 plus 0. We're going to have 1. And then 1 plus 1, we're going to have 0 with a carry of 1. That carry we have, it means that we're going to bring it down to this part. So it's going to be the final bit we're going to have. So therefore, we're going to have 1 0 1 0 0. So this is how we carry out the addition operation in binary. Now let's check. Now remember this formula, okay? The direct method for converting binary to decimal and decimal to binary. Now you have 2 raised to the power 3. Since the numbers of bits we have in this point, it means that the radix, the raised to power is going to be 3. Since the numbers of bits we have is 4. So we're going to have 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1, 2 raised to the power 0. So that will give a total of 4 bits. So we have 8, 4, 2, 1. Remember this formula. Now we know that 1001, if we have to convert this binary to decimal, is going to be 9. Because in this case, where you have 1, 8 is present. Where you have 0, 0, 4 and 2 is absent. When you have 1, at this point, 1 is present. So when you sum 8 and 1 together, you're going to get 9. So the same for 1011. If you have to convert that to decimal, we're going to have 11. Because this is 8. 8 plus 2 plus 1 is going to give us 11. So if we have to do the summation of 9 and 11, we're going to have 9 plus 11 is going to give us 20. Now can you see that? This is to check if the summation was correct or not. Alright, so in this case 20 will be equivalent of 10100, which is the same as the answer we got at this point. So if we have to check if this is equivalent to this, all we need to do, knowing fully well that this is 1 2 3 4 5, we have 5 bits. So it means the highest number of our radix, the highest number of the raised to power is going to be 4. Alright, so we're going to have 2 raised to power 4, 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, and 2 raised to power 0. Alright, so we know that this is already in base 2, which has a radix of 2 already. Okay, this is base 2. Alright, so base means the same thing as radix. Okay, now when you say 2 raised to power 4, we're going to get 16, 2 raised to power 3, 8, 2 raised to power 2, 4, 2 raised to power 1, 2, and 2 raised to power 0 is 1. Alright, so if you have to convert this binary into decimal, we're going to say at this point where you have 1, it means 16 is present. 0 means 8 is absent. So 4 means 1 at this point means 4 is present. So we say 16 plus 4, it's going to be 20. And then when you have 0, 0, it means what you have is 2 is 0, 1 is 0. So in this case, we've been able to prove that 20 is equivalent to 10100. So this shows that the addition of these two binary value is correct. So alright then, pay close attention to the subsequent videos in this channel. Enjoy this video. Bye.